Right now, almost every AI application you're using is built like a house, where the roof is glued directly to the walls. You can't change one without the whole thing falling apart. That's the fundamental problem Vercel CEO Guillermo Rauch just laid out, and it's breaking the entire AI industry in ways most people don't realize yet. Here's what's happening. Modern AI systems are built with the model and the agent completely tangled together. The model is the brain that predicts the next word or decision. The agent is the thing that decides what to do with that prediction, when to stop, what to try next, whether to ask for help. They're supposed to be separate components, like an engine and transmission, but right now they are soldered together. This matters because it means every time someone wants to use a better model, maybe a faster one, cheaper one, or specialized for their use case, they have to rebuild their entire application around it. They can't just swap the engine, they have to rebuild the car, and it gets worse. When models are tangled with agents, errors cascade in unpredictable ways. A hallucination from the model gets fed into the agent's decision-making. The agent makes a bad call based on that hallucination. The whole system goes off the rails, and nobody knows exactly where it broke. Rauch is saying this architecture is fundamentally wrong. But here's the twist nobody expected. The way we got here is actually pretty straightforward. About 3 or 4 years ago, everyone realized that combining a large language model with an agent framework could create genuinely useful AI applications. You could build a chatbot that could actually do things, not just talk, but take actions. So companies started bundling them together. OpenAI built agents into ChatGPT. Google integrated agents into Gemini. Meta did the same. Every startup that wanted to compete just mashed them together in their own app. It worked. Things were useful. The problem was invisible at first because the models were still improving so rapidly that nobody cared about the architecture underneath. But then things started slowing down. The model improvements got smaller. The quality gains got harder to find. And suddenly, the architectural problems became obvious. If you built your entire company around Claude 2, and then Claude 3 came out with a totally different API or behavior, you couldn't just upgrade. You had to rewrite your whole agent logic. It's like building a restaurant around one specific chef. When the chef leaves, you don't just hire a better chef, you have to rebuild your kitchen, your menu, your ordering system, everything. Every restaurant did this. Every single AI company made the same architectural bet, and they all got trapped. That's when Guillermo Rauch started saying this out loud. We built this wrong. We need to separate them. Let's zoom in on why this matters technically. The problem isn't just philosophical, it's about how errors propagate and how systems fail. An AI model's job is to predict what comes next based on patterns it learned. It's phenomenally good at this in normal cases, but it hallucinates. It confidently predicts things that are completely false when asked about something it hasn't learned well. That's just what these systems do. They fill gaps with confident guesses. An agent's job is to make decisions. Should I ask the user for clarification? Should I search the internet? Should I try a different approach? Should I stop and give up? The agent is supposed to be skeptical and verify things. It's supposed to catch when the model is hallucinating. But when they are tangled together, the agent trusts the model. It treats the model's confident guess as reliable information. The hallucination gets baked into the decision-making. The system makes choices based on false information, and suddenly you've got a cascading failure. Separating them means the agent can say, I don't trust that prediction, let me verify it independently before I act on it. It means you can run the same agent with different models and get different results. It means you can test the agent's logic independently from the model's accuracy. It's the difference between a system that's fragile and one that's resilient. And here's where it gets interesting. So what happens in the real world when models and agents are tangled together? The failures are spectacular and unpredictable. A financial services company built an AI agent to help analyze investment opportunities. It bundled the agent with a proprietary model trained on historical market data. The model worked great in testing, but then it hit a real-world edge case, a market condition it had never seen before. The model hallucinated. It confidently predicted a trend that didn't exist. The agent, trusting the model completely, made a trade recommendation based on that false prediction. The client lost money because there was no separation between the model's guess and the agent's decision-making. Or take a customer service chatbot. The model generates a response. The agent decides whether to send it to the customer or escalate to a human. But the agent doesn't have a way to validate whether the response is accurate. It's too tightly coupled to the model. So the chatbot sends bad information to customers. When you complain, there's no fallback. The whole system breaks at once. Here's the kicker. In a separated architecture, both of these problems become fixable. The financial agent could validate the model's prediction against real-time market data before acting. The customer service agent could fact-check responses against a knowledge base before sending them. The agent becomes the safety layer, not just a decision maker. This is what Rauch is pushing for: architectures where the agent can say no to the model. Let me show you the difference between bundled and separated architectures. It's actually pretty simple once you visualize it. In the bundled model, everything flows in a straight line. Request comes in, goes directly to the model produces output, the agent decides what to do with it. The agent is just a thin wrapper around the model's decision. If the model hallucinates, the agent probably will too, because it doesn't have independent verification. In the separated model, the agent is in control. A request comes in. The agent decides what information it needs. It might call the model to generate text, but it also calls other tools. It might search the internet, query a database, run a calculation. The agent assembles all of these answers and makes a decision based on the combined evidence. The model is one input among many, not the truth source. Think of it like the difference between a student who just trusts their textbook versus a researcher who reads the textbook, but also checks primary sources, interviews experts, and validates claims independently. The researcher makes better decisions. The separated approach also means you can upgrade models without rewriting your agent. A new model comes out that's faster, cheaper, or more accurate. Your agent can just start using it. It's plug and play. No rebuild, no retest, no massive engineering effort. Companies like Anthropic and Vercel are building infrastructure specifically for this separation. And this is where things get surprising. If this architectural change happens industry-wide, it changes everything about how AI gets built and deployed. Right now, if OpenAI releases a new model, every company using ChatGPT as their base has to decide, do we upgrade? And upgrading means testing everything again, potentially rewriting code, managing the risk that the new model behaves differently. It's expensive and risky, so a lot of companies just stay on old versions. The industry gets fragmented. You've got ChatGPT users stuck on version 3.5, version 4, version 4 Turbo, all running different code because the models aren't interchangeable. With proper separation, you upgrade the model in seconds. Your agent continues working. The whole industry can move faster. There's also a competitive impact. Right now, companies that own the best models have enormous power. They own the application layer too, because everything's bundled together. If models become truly interchangeable, a startup could build an incredible agent and pair it with whatever model is best that week. The model makers become commodity providers. The power changes to whoever builds the best agents. That's a massive industry realignment. It threatens the moat of companies like OpenAI that built their value on bundling. But it also means smaller companies and startups get more leverage. It also means safety gets better. When agents and models are separated, you can add safety layers in between them. You can verify outputs. You can detect hallucinations. You can build guardrails that work regardless of which model you're using. But here's what the headlines aren't telling you. So how do you actually build an AI system with models and agents separated? Vercel and other companies are starting to show the way. The first step is treating the model as a service, not as your core logic. You define a clear API. The model accepts a request and returns a response. That's it. No context bleeding over, no agent logic baked into the model's training or fine-tuning. The second step is building a real agent layer that's independent. This agent has access to multiple tools. It can call the model, yes, but it can also call a search API, query a database, run a calculation, ask for human input. The agent decides the workflow. The agent orchestrates everything. The third step, and this is critical, is building a validation layer between them. After the model produces output, something checks it before the agent acts on it. Does it make sense? Is it consistent with other information we have? Does it contradict the knowledge base? If validation fails, the agent tries a different approach. Vercel's new frameworks are specifically designed around this separation. They make it easy to define agents that use models as components rather than as the foundation. Other companies are following suit. The tools that enable this are getting better every month. Orchestration frameworks that were impossible 2 years ago are now straightforward. Here's what this means for you and what you should watch for over the next few months. If you're building AI applications, this architecture change is coming. It's not optional. The companies that separate models from agents will be faster, more flexible, and more resilient. The ones that keep them bundled will get stuck when models change or when they need to switch to something better. If you're investing in or working at an AI company, this matters because it determines whether your tech stack is future-proof. Companies that bet on bundled architectures made a bet that one model provider will remain dominant forever. That's a bad bet. If you're just using AI tools, this change means better performance, more reliability, and less downtime when models get upgraded. It means fewer hallucinations because agents can validate outputs. It means your AI tools will get better faster because the entire industry isn't locked into waiting for one model provider to innovate. Watch for 3 things. First, how many companies announce that their agents are now model agnostic. That's the leading indicator that the change is happening. Second, which AI infrastructure companies start building tooling for separated architectures. That's where the engineering effort is going. Third, whether model providers start treating themselves as commodities or keep pretending they're the whole solution. Guillermo Rauch is saying out loud what the entire industry is starting to whisper. We built this wrong, and we are going to rebuild it right.